Okay, we're going to use inverse trig equations today. So if you notice, we're going to be solving for an angle for each of these equations. The sine of inverse of x is equal to the arc sine of x. So if you use your calculator to find an answer, an angle answer, you're going to get an answer in quadrants 1 and 4. The rest we are going to calculate for. For cosine, the principal quadrants are 1 and 2. The rest we will have to calculate. In tangent, our principal quadrants are 1 and 4. So when we do these types of problems today, if you're using a calculator, you're going to get one answer in your principal quadrant, and then we need to calculate on our own the answer from the other quadrant. So let's start with the sine equation. So what kind of solutions will sine x equals root 2 over 2 have? Well, what is root 2 over 2? That's the ratio of sides. So that means that x is an angle. Okay, how many solutions, if we look to the left, when will sine of x equal root 2 over 2? Well, we got, looks like here, 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 and so on and so forth. So, in the end, we're going to have infinitely many solutions. So we're not just limited to angles from 1 rotation or 2 rotations or 3 rotations. This sine curve goes on forever, so we're going to have forever solutions. Okay? So what if we do limit our answers to 1 full rotation, so 0 to 2 pi? When will the sine of x equal root 2 over 2? So thinking about my principal quadrants first, sine is positive in the first quadrant, so I know sine x has a ratio of root 2 over 2 when my angle is pi over 4. So from the first quadrant, x is equal to pi over 4. But the problem is where else is sine x equal to root 2 over 2? Well, you know, in the in the second quadrant here. Sine is also positive. But our calculator didn't give us that answer. We have to be smarter than the calculator and get it ourselves. So what we're going to do is take, for sine, I'm just missing pi over 4. So my angle is going to equal 3 pi over 4. Or that's 180 pi minus pi over 4, which is equal to 3 pi over 4. So I actually have two answers here, two places where sine of x is equal to root 2 over 2. So what if this graph went on forever? How do I show all answers, all possible answers? What we're going to do is we just add in our coterminal angles. So we write x is equal to pi over 4 plus, how do we get coterminal angles? Add 2 pi n. In quadrant 2, we get x is equal to 3 pi over 4 plus 2 pi n. So instead of listing out all angles forever and ever, we just make an equation for it. All right, next, cosine equation. So when is cosine x equal to negative root 3 over 2? Well, let's look to see what is x. X is, an angle. And how many solutions, if this graph keeps going on forever, how many angles, I guess, will yield a ratio of negative root 3 over 2? If it goes on forever, the angles will also have infinitely many solutions. I can see them. Here, 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 here. Will this graph ever stop? Nope. So we're just going to keep having intersection points. All right, we're dialing it back to one full rotation again. So when cosine x equals negative root 3 over 2, what angles will give me a cosine ratio of negative root 3 over 2? So where's cosine negative? Cosine is negative in the second and the third quadrant. Which one is the principal quadrant for cosine? Remember, these two are principal quadrants. So if you use a calculator, your angle will be in the second quadrant, negative root 3 over 2. So right here, this is the angle pi over 6. So that means that theta is equal to 5 pi over 6, 1 less than 6. Okay. So in the second quadrant, we get x is equal to 5 pi over 6. And then how do we get the angle from the third quadrant? Well, cosine's really nice, and I can actually move this way. How big is this angle? This is theta is equal to negative 5 pi over 6. So whatever you get from your principal quadrant is just going to be negative for the second answer. Okay. How do I get all possible angles? Well, I'm just going to say quadrant 2 is 5 pi over 6 plus 2 pi n, and quadrant 3 would be x is equal to negative 5 pi over 6 plus coterminal angles 2 pi n. Oh, you know what I forgot is that n is equal to any integer, and it represents adding or subtracting full rotations around the circle. Okay. Lastly, we have tangent. Tangent is, so what kind of solutions are we looking at in this type of equation when we have a tangent of x? Well, we're looking for an angle. If tangent of x equals negative 1, looking at tangent and our graph at negative 1 here, tangent has many places where we intersect negative 1. So as this pattern keeps continuing, we're just going to get an infinite number of solutions. So infinitely many solutions. All right, so what quadrants are our principal quadrants for tangent? That would be quadrant 1 and quadrant 4. And where is tangent negative? In quadrant 4 and quadrant 2. So I'm going to go ahead and draw in a tangent with a negative 1, so root 2 over 2, and negative root 2 over 2. So a negative divided by a positive would give me a negative. And so I'm going to see in quadrant 4, x is equal to, let's see, we're moving this way, and this is a pi over 4 angle, so negative pi over 4. Lucky for us, in quadrant 2, if I draw my triangle over here, this is pi over 4. All tangent answers are always opposite of each other by exactly, or they're on the other side of the circle from each other by exactly pi. They're pi units away. So for quadrants 4 and 2, we can just say x is equal to negative pi over 4, so from our fourth quadrant, plus every pi n, where n is equal to integers, any integer, and that represents a half rotation. So luckily, we also listed all the possible solutions. So again, x is equal to negative pi over 4 plus pi n. That would be all of our solutions. So actually, we need to go back here. For quadrant 2, what is the angle measure? If I add one rotation, n would be 1, so x would be negative pi over 4 plus pi times 1. So sorry, excuse me, if I add a half a rotation. So that would give me negative pi over 4 plus 4 pi over 4. So x is equal to 3 pi over 4. So I have two places, 3 pi over 4, and when x is equal to negative pi over 4. What would I need to do to get, since this angle is negative, and it says that I want to be in the range of 0 to 2 pi, what do I need to do to get back into the fourth quadrant? Well, I can just add 2 pi. So x is equal to negative pi over 4 plus 8 pi over 8, which is equal to 7 pi over 4. So these are our two answers here.